Nuclear equations are similar to chemical equations in that the sum of the mass numbers, so the sum of the mass numbers are equal, and also the sum of the atomic numbers are equal. So since the mass is conserved, we can treat them in some simple ways to figure out what particle might be missing from an equation. The nucleus changing throughout the nuclear reaction. Let's do a few examples where we can solve for unknowns. Now, in order to do these problems, we'll need to know the particles that could form. So here's the particles. We could have an electron. Remember, the mass number is shown on the top, the atomic number is shown on the bottom, or charge. So an electron, 0 over -1, neutron, 0 over 1, atomic number of 0, charge of 0. A proton is shown with a hydrogen symbol since it has a atomic number of 1 and a mass number of 1. A positron is 0 over 1 e, so that's a positively charged electron. And then one more, 4 over 2 he, this is an alpha particle nucleus. So let's say we have, for our first example, 28 over 13 aluminum decays to make an unknown plus 0 over -1 e. So what particle is that? Well, that's an electron. So we need to find the unknown particle that gets reduced when the aluminum decays by beta emission. It releases a beta particle. What's left over? Well, we could think conceptually. Beta decay occurs when a neutron turns into a proton and an electron. So we would expect the protons to increase, the atomic number to increase, and the mass number to stay the same. But another really easy way to do these problems is to use algebra. So since we just saw that we have equations where the sum on the left is equal to the sum on the right, we can use simple algebra to solve for an unknown in that situation. So we can say 28, I'm going to make two equations, one for the numbers, one for the atomic numbers. So 28 equals, put an equals instead of the arrow, x, my unknown, plus 0. 28 equals x plus 0, so all the top numbers. And we do the same for the bottom numbers. 13 equals the unknown y plus -1. So now if we solve for x and y, x equals 28, and y, we would add 1 to both sides of this, so y is 14. Now we just look up the element that has atomic 14, and so that's silicon. Let's try this one. An unknown particle bombards sulfur 32, which produces phosphorus. In this example, plus 2, 32. 32 is 0. On the bottom, y plus equals 15. Subtract 16 from both sides. 15 minus 16 is negative 1. Negative 1. So in this case, we can see that 0 over negative 1 drawn. So it was a beta particle that bombarded this reaction. How about this example? Let's say we have 4 over 2 He plus 27 13 Al makes 30 over 50 phosphorus plus 1 over 0. All right, so let's try that one. Just messed up on that one. So let's try that again. We have try a different one. So we have 4. Let's do this one instead. So we have 1 over 0 n plus the unknown makes 24 over 11 Na plus 4 over 2 He. All right, so again, similar approach. N, so this is a neutron here. We have 1 plus equals 24 plus 4. So this is going to be 28, and we'll subtract 1, so 27. And then we have plus y equals 11 plus 2. So that would be 13, and 30 is y. Look at the element. Atomic number 13 is aluminum. And there we go. Now, let's look at the situation where we have equations that are written out, so that we have to now figure out. So this is writing nuclear equations from descriptions. So for the first one, we have if nitrogen 14 turns into oxygen 14 in the presence of radiation, what type of particle is emitted? So we have to read this equation and figure out how to write the equation from the words. Now, emitted means release, but let's start with the beginning here. So we have nitrogen 14, mass number is 14, turns into oxygen 14, and the atomic numbers we can look up. So it's 7 for nitrogen, and for oxygen 8. Now, emitted means release. Let's think about these other examples here. So for instance, in this example, the electron was emitted during this process. Notice it's on the right. It's like this. We have one thing, and it emits something else. So a piece of that comes out. So we can see that when something gets emitted, a particle gets emitted, that's going to be shown on the right side as a product. So if it said it was added to the other thing, then it would be on the left side. But since it's emitted, it's being released. So now we go through this in the same process as before. 14 equals 14 plus x. And on the bottom, 7 equals 8 plus y. So 14 minus 14 is 0, 0 on the top, and 7 minus 1 is negative 1. And we see we have then, once again, an electron, 0 or negative 1, or beta particle.